Hi everyone, good day. I'm Yvonne Wong from Singapore University of Technology and Design. Today I'll be presenting on our paper, Teaching Structures to Architects. I will walk you through our new pedagogical framework on how we teach students to think, experience, communicate, and design. The communication gap between architects and structural engineers are well known. Hence, this pedagogy study was proposed to bridge the gap between them. This is done through reviewing teaching methods for architectural students. This study was applied to a Year 2 core module called Architectural Structures and Enclosure Design in our university. The learning objectives for this course is for students to articulate structural system design, its function, its intended goal, and also the essential working elements. Traditional methods of teaching structural design to engineering majors typically begin with member or nodal scale. The flow of learning should be zooming out from structural members to global analysis of the whole structure. However, we believe that this flow of teaching may not be applicable to architecture students, and instead we introduce another flow for this course. Since architectural students are more interested in the artistic representation of the final structure, we decided to adopt a zooming in approach for our flow. The whole concept of the flow was to simplify things in the beginning while keeping it interest in learning for the architectural students. As understanding of the basic behavior in 2D, we then focus on more complicated and necessary concepts in structures. With the flow in mind, this is the 14-week finalized course structure and the topics covered for the course. The teaching method for this course is a weekly 2-hour lecture with a full cohort, followed by 3-hour seminars with the students split into 2 groups. I will now elaborate on how this pedagogy shapes the students to think. The seminar exercises themselves adopt a combination of teaching methodologies. Project-based learning is applied through seminar assignments where students have a week to complete a graded design project. The studio-based learning is applied where students first construct an artifact. They are then given critique on their work. The overall teaching methodology of the seminar session is the active learning method. We have adapted the learning methodology in a structure such that students were first given an introductory hands-on design exercise to work on in their small groups. They were then presented a solution and given feedback as the models were directly tested on. At the end of the session, consolidated general lessons from all these attempts were given, and on top of that, good strategies that were not tested were given to them. A final assignment, which is a further extension in both complexity and scale, would be given to them for a week to work on. For example, in our first seminar, we made them design with paper one-way spanning roofs. When they understand the behavior, for the take-home assignment, we went on to 2-way spanning roofs. This idea and pattern is repeated in the other seminars. In the same fashion, you could see in seminar sessions 3 and 4, the same increase in complexity of exercises are shown. For example, from a simple member, we go on to a hanger. From a simple truss member, we went on to a tower design. I'll now elaborate further on seminar sessions 2 and 4 in particular to show how students learn through experiencing. We created these mechano strips ourselves by using laser cutting of thick boards and split pins. So these exercises involving mechano strips were very effective to help the students visualize how members behave by external loading. This is done through building the different configurations you see here and loading them with their hands. The students could feel and understand the effect of the different scenarios and thereby strengthening their intuition. Hands-on learning has also been proven to be an effective way to teach statics to students, where students are able to work with the example either by manipulating with their hands or by seeing the resultant deformation or motion. The benefits of kinesthetic learning in structures is that students can translate the behavior of forces into actual experiments where they can experience and then apply this knowledge to their later design thinking process. The whole nature and idea of the seminar sessions is a competitive gamification to explore design solutions. Through this process, the students will learn how to communicate with each other. The introductory exercises for seminar sessions is targeted to be small hands-on design activities set up to be design competition among the groups. The reviews of the take-home assignment will also mainly load testing competition of the models. Let's now take a look at a short video of the introductory exercise. Here you can see that the introductory exercise is a simple single spanning rule, and it can only take a few nuts and bolts. But above, for the take-home exercises, their model can now take a much larger load. We believe that students were able to learn from each other group and how different solutions were achieved, and a sense of competition in the seminar session makes the sessions more engaging and encourages the students to learn more through finding solutions. Here we also show one of our favorite assignment, the GIF competition. The final assessment was intended to allow students to bring all their skills together to design. It coordinated its deliverables with a parallel course on digital fabrication. For this year's run of the course, it is required for students to design, fabricate, and test a full-scale large model of a bridge. Coherent to the theme of all the seminar sessions, this too allowed us instructors to destroy the students' models. In summary, with the new pedagogical framework, it has shown to be effective in meeting learning objectives. Students can articulate structural behavior and concept with more confidence. The outcome is their ability to integrate form and function. Comments from observing Professor Kanao identifies that planning and execution of the final outcome are more rigorous and resource-intensive. Also, actual mathematics and structural calculations performed by students are less compared to her home university KIT. More emphasis instead were placed on digital tools and modeling skills for students in SUTD. Thank you so much for your attention.